Hi everyone, I am Sunny Kumar from Mathematics and Computing Part 2 from IIT BHU, and I am back again with another question of AtCoder Beginner Contest 190 F type shift and inversions. So in this question we have been basically given an array which is a permutation of first n integers starting from 0, and we have been basically given an value k starting from 0 to n minus 1, and we have to find the inversion number of the sequence of array B, which is basically there are it depends on the value of k. That is, if k is 0, the array A is shifted to the right by 0, and if k is 1, the array A is shifted to the right by 1, and correspondingly, and we have to find for each array B for values k equal to 0 to n minus 1, we have to find the inversion number of all the particular arrays of B corresponding to value of k. Now you can see that n varies from 2 to 3 into 10 power 5. Now one thing you can notice that there are many approaches of this question. Uh, if if we go for the naive approach, that is, write the array B each time after shifting array A by the value equal to k that is being given, you can find that the time limit is very strict of this question, that is 2 seconds, and your code gets time limit exceeded. Also note that inversion number of any array can be calculated using a policy based data structure of C++, that is using ordered set, or you can find using Fenwick tree, or you can find using a merge sort technique. Now what this question says, how we can efficiently calculate for all the values of k, which is ranging from 0 to n minus 1, and the n goes from 3 into power 5. So how we are going to calculate this value efficiently? Let us move to the how we can understand this question mathematically. Suppose we have been given an array, suppose n is 5, and okay, I am going to take n as 5 here, and suppose the values are like 1 0 3 4, and let's say 2 we have here. So you can number of inversions would be number of pairs of I comma j in the array such that we have a of I must be greater than a of j. Now in this array you can find that there are let's calculate this. We have 1 comma 0 as a pair. I am mentioning the values, okay, and we have let's say we have another 3 comma 2, okay. 1 0 is a pair, and the let's fix I, that is at here at I equal to 0 index, and there is no j, that is first j is at 0, and for 0 value there is nothing, there is not of the pair because 0 is the minimum, and for 3 there is a 2, and for there is another pair comma called 4 comma 2, okay. So number of inversions would be 3 in this array. So now the question says this is for, okay, let me mention here, this is for k equal to 0, okay. Now if k equal to 1, so our new array would be like what? Our new array would be 1 is going to be popped out from this, and it is going to be appended to backside. So our new array would be 0 3 4 2 1. So if we are going to calculate this new array's inversion count separately using Fenwick tree or a ordered set or a mm, or let's say or a merge sort technique, the time complexity is going to be, if we will use merge sort, the time complexity is going to be you like n square log of n, and if we use ordered set it would be like n square log of n, something like this type. But we know we have to calculate this inversion count of our new array in most efficient way. So how we are going to calculate this? So notice the observation. What is the observation here? If we are going to uh, find Find the change in inversion count due to first elements first element position change. Okay, now when one is going to be removed from here and it is going to be appended to the back. Now for let's find the number of inversions due to the element 1. So how we are going to calculate this? Let's mention those pairs, that is only 1 comma 0. So the in the previous inversion count, that is in this array, you can observe that uh, number of pairs that are contributing to the inversion count is 1 comma 0 due to the element 1. And if one is going to change its position and it is going to be popped out from here and it is going to be appended to the back side, notice that the change in inversion count due to change in the position of 1 would be like number of elements that are going to be less than 1 and are at the position at more than index of 1, that is number of j such that j is greater than 0, like because the first element is always popped out. Number of and array of j is going to be strictly less than array of 0. eh, this is for old position of array of 0, that is if 1 is at here, number of j such that j is positive and j is greater than a0 would be for old position of a0, that is for 1 it would be 3 and 4 and 2. And you notice that these are not contributing in inversion count. And number of j such that j is greater than 0 and array of j is strictly less than array of 0. This is for old position of a0. As you can see, old position of a0, and you can see these are contributing in inversion count. As you can see, a number of elements such that j is positive and j is array of j is less than a0, that is 0 is less than 1. These are contributing in inversion count of previous arrangement of the array. Now our new arrangement would be, sorry, there is a typing mistake. Arrangement would be New arrangement would be 0 3 4 2 1. Now if we look for the element 1, then one keen observation you can see that how the inversion count due to 1 are occurring. So let me write inversion count due to 1 would be, you can notice, is 3 comma 1 and as 4 comma 1 and as 2 comma 1. Okay, the inversion count is going to be 3 due to 1. So there is a one observation that you can notice is when element is going to be popped out from beginning and it is going to be appended from the beginning, inversion count new would be, there is a relation that we can obtain our new inversion count from the previous inversion count after popping the first element, and there is no there is no requirement of calculating using another Fenwick tree, another merge sort technique to calculate the new arrays inversion count. We can calculate this inversion count from our previous inversion count in most efficient way. So our new inversion count would be previous inversion count, that is, and how the change plus change. So how we can write this change? So let me write previous inversion count, and inversion count is going to be decreased. As you can see now, the inversion count is actually the for 10 in the previously, and now inversion count is for 13, 14, 12. So inversion count is decreased by the number of elements that is strictly less than the current value. So because here you can see inversion count is contributed by those elements that are strictly greater than 1, and here inversion count is going to be contributed by those elements that are strictly less than 1. So our previous inversion count minus number of elements that are strictly less than 1 is actually, you can notice it is array of 0. You can notice if number of elements that are strictly less than 1 is actually 0, so previous count minus array of 0, and the inversion count is going to be increased by those elements which are strictly greater than the current value, that is 1, that is strictly greater than 1. Here you can notice 2, 3 and 4. So if you can derive a formula for this, it would be like n minus 1 minus v0. Here n is 5, 5 minus 1 is 4, 4 minus 1 is 3. As you can notice here it comes also 3. So it's a bingo actually. So there is a formula, that is, here you can use previous count of inversions minus current value of array plus n minus 1 minus v0. So what we are going to do is we are going to calculate the inversion count of the current state of at the array, and we are going to find out all the inversions count due to the shifts, that is because of k equal to 0, k equal to 1, 2, 3, so up to n minus 1. So I am going to write a general thing to calculate, to find out the solution of this question. Inversion Calculate inversion count of for k equal to 0. That's what you need to calculate inversion count for k equal to 0, sorry, k equal to 1 to k equal to n minus 1 using previous inversion counts. Okay, and you are going to do this, sorry, you are going to go for k equal to 0 using Fenwick tree or ordered set, or you are going to use a merge sort technique. Okay, now the actually I've explained everything the most efficient way, though let us move on to the code section, how we are going to implement this and find out the best possible way to approach our answer. So notice that I've mentioned an global variable n, and I'm going to start the our Fenwick tree here. In this I've used Fenwick tree to calculate the inversion count, which is the most best way I think I can use this. So here is the sum function which is going to calculate the prefix sum from bit array, and here I have a bit array that is actually implementing our Fenwick tree. Now I'm going to update this using a word add function. And if you have some doubts in Fenwick tree how we are going to implement our Fenwick tree, so I have already mentioned a link in the description section of the video, so do not forget to watch this also. Now I have a answer variable which is going to store answer. I am going to assign our bit, that is binary index tree, with default values, that is 0. Now what I am going to do is I am going to use this, I'm going to iterate from the back side of the array, and I'm going to get inversion count for the current array element. So our current array element has inversion count equal to the current state of prefix sum of bit array, and this you need not to, sorry, you did not to worry about this. I have also mentioned how to calculate a number of inversions for using a Fenwick tree in my description section of the video, so do not forget to watch that also. Now I have printed my answer for k equal to 0. Now one thing you can also notice, that for I equal to 0 to n minus 1, I am going to do this for our values for next values, sorry, I'm going to pop out the first element and I'm going to append this. So what will be the change? We need to subtract from the contribution of the first element in the permutation and then add its new contribution when it is the last element of the permutation. So basically we are going to subtract vi because its inversion count going to be decreased when it is popped out and appended to the back, and the inversion count is going to be increased when it is appended back to the array by the value equal to n minus 1 minus vi, that is the current state of the value, that is v0. Okay, vi is going to handle the ith state. Okay, now I'm going to print our answer for every value of vi. Okay, so the question is somewhat tricky and it comes under the hard section of the questions in general. So you need not to worry about. I have explained it very clearly. So if you have any more doubts in this question, so do not forget to mention in the comment section of the video, and I will ask the viewers to like this video, share this video, and I have mentioned my Telegram link in my code description section of the video. So do join that too, and thank you for watching this video.